Hi, hello and welcome to another session on data communications and networks. In the last session we have seen the error correcting code. So in today's session we'll see one example based on the error correcting code. So let's get started. So we'll see an example using the error correcting code. So here in the previous session we have seen the relationship between the data bits D and the redundant bits R. So this is the relation. 2 raised to R should be greater than or equal to D plus R plus 1. For example, we'll take D is equal to 4. So we need to compute the value of R. How many redundant bits are to be added, that has to be calculated. So we'll take 2 raised to R is greater than or equal to 4 plus R plus 1. If R is equal to 1, so this is not satisfied. Now take R is equal to 2. Four plus 2 plus 1. So this is also not satisfied. Take R equal to 3. This is 4 plus 3 plus 1. So this side we get 8. This is also equal to 8. So 8 is equal to 8. So we can take the number of redundant bits is equal to 3. So for the data bits, 4 data bits, we can take 3 redundant bits. So by using the same, we'll do an example. Now we'll take D is equal to 1 0 1 0. That is 4 bits of data. So we need to add 3 redundant bits. So here we need to consider some points. For the first redundant bit, these are the bit positions 1, 3, 5, 7. For the second redundant bit, we need to consider 2, 3, 6 and 7. For the next redundant bit, we don't write it as R3, it is written as R4. This is 4, 5, 6 and 7. Now we'll see why it is not called as R3 but it is R4. So if you see the first one, R1, so these depend upon these bits. It is 2 raised to 0, the first one. Second is 2 raised to 1, this is 2 square. So 2 raised to 0 is 1, 2 raised to 1 is 2, 2 square is 4. That's why we write the redundant bits also as R1, R2 and R4, not as R3. We need to remember another table to find the error bit position. And the position numbers. So if there is an error in the 0th bit position, there is no, we have to consider it as no error. So this is written as 0, 0 and 0. If there is an error in the first bit position, we get the position number as 0, 0, 1. For error bit of 0, it is 0, 1, 0. For the error bit of 3, it is 0, 1, 1. For 4, it is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. And 7 is 1, 1, 1. Now we'll do the example by using this data bit 1010. So here D is equal to 1010. So we'll draw the data bits 7, 6, 5, 4, 3, 2 and 1. So this is the data bit D4. We have 4 data bits, so that is D4, D3, D2 and D1. And the redundant bits are present in the positions R1, R2 and R4. We'll write the bits. Now first write the data bits. It is 1, 0, 1 and 0. So this is the given data bit. It is 1, 0, 1, 0. In the next step, we need to find the value of R1. So in this step, add R1. First write the data bits 1, 0, 1 and 0. Now to find the R1 position, we need to consider 1, 3, 5, 7. These bits are to be considered for even parity. The 7th bit is 1, 5th bit is also 1, 3rd bit is 0. So to get even parity, we need to insert 0 in this position. Therefore, R1 is equal to 0. So insert a 0 in position of R1. So this is how we need to calculate the first redundant bit. Next, to calculate R2. Again draw the same box. Write the data bits first 1, 0, 1, 0. We already computed the R1 bit, so write that also here. So here we'll add R2. To find R2, we need to consider the positions 2, 3, 6, 7. 7th bit is 1, 6th bit is 0. The 3rd bit is 0. Now to get even parity, here we need to insert a bit of 1. So we get R2 is equal to 1. So put a value of 1 in place of R2. So this is how we get the value for R2. Next we need to find R4. Again draw the same box. Write the data bits 1, 0, 1, 0. Write the redundant bits which we have already computed, that is R2 is 1, R1 is 0. Next we need to find R4. For R4 we need to consider the positions 4, 5, 6 and 7. 7th bit is 1, 6th bit is 0, the 5th bit is 1. To get even parity, here we need to put a 0. So that is the value of R4. So R4 is equal to 0. So put value of 0 in this place. So this is the data which is to be transmitted. One, 0, 1, 0, 0, 1 and 0. So this is the data transmitted. So we'll write the data transmitted. It is 1, 0, 1, 0, 0, 1, 0. Now suppose we have an error in one of the bit position and the received data, and so we'll suppose this is the received data which is having an error in one bit position. So this is 1. We'll consider that there is an error in this position. So here we have a 0, we'll change it to 1. Sorry. This is 1, 0, 0, 1 and 0. So we'll suppose that this is the received data. Now we need to find out in which bit position there is an error. So to calculate that, we need to consider the C1 bit. If you remember the previous table, according to these positions we need to calculate in which bit position there is an error. So first we have to take the values 1, 3, 5 and 7. So this is the 7th bit, this is the 5th bit, then we have the 3rd bit and the first bit. So this is 1, 2, 3, 4, 5, 6 and 7. So we need to consider 1, 3, 5, 7 to compute the first bit error position. This will write it as C1. So here we need to again consider the even parity. So this is for C1 we have 1, 3, 5, 7. So the first bit position is, this is 0, 3 is 0, 5 is 1 and 7 is also 1. So already even parity is there, therefore value of C1 is equal to 0. So put a value of 0 here. Next we need to calculate the value of C2. To find C2 we need to consider 2, 3, 6 and 7. So this is 7, 6, bit 3 and the bit 2. So this is C2. So for C2 we need to consider 2, 3, 6 and 7. The second bit is 1, third bit is 0, 6 is 1 and 7 is 1. So if you see, we are having an odd number of bits here. So we need to add an extra 1 to make it as even parity. So the value of C2 is equal to 1. So put a 1 here. Next, we'll calculate C3. To find C3 we need to consider the bit positions 4, 5, 6 and 7. 6, 7, this is 5 and this is 4. So this is the value of C3. So for C3 we need to consider 4, 5, 6 and 7. 4 is 0, 5 is 1, 6 is 1 and 7 is 1. So if you see, odd number of ones are there, so the bit to be added is 1. So that is the value of C3. So put a value of 1 here. Now this code, you can write it as C is equal to C3, C2 and C1. This is equal to 1, 1, 0. So if you convert this into decimal, this is the 6. So there is an error in the 6th bit position. So correct the error in the 6th bit position. There we have 1, 1, 1, 0, 0, 0, 0, 1 and 0. So there is an error in the 6th bit position. Hence, correct the 6th bit position and the corrected code is equal to 1. Make the 1 as 0. Here we have a value of 1. Make it 0, 1, 0, 0, 1 and 0. So this is the data which is which we got after correction. So this is how we compute the error correcting. I hope I am clear. So in the next session we'll see one more example based on the same error correcting course. Thank you.